Hello, I'm Chuck Black, and welcome to this section where we dive a little bit deeper into object-oriented programming. Specifically, in this particular section, we're going to look at the idea of inheritance, the idea of composition, and the idea of encapsulation in object-oriented programming. So first, let's look at inheritance. This is one of the fundamental concepts that comes with object-oriented design, object-oriented systems, and object-oriented programming. If you look at this picture up here on the right, you'll get the general idea of what we're talking about. What you will end up doing is you will end up defining a common or parent or base class for a particular item that you are attempting to model in your application. In our case, we're modeling a network device. And this common model piece right here is going to be generic. It's going to contain information that is common to all different types of devices. And then what we will do is we will define child or subclasses that we will use to define specific details and nuances of all the different device types. So as you can imagine, an iOS device is going to have a little bit different capabilities than an XR device. And as we look over here, you can see that we have defined the base class of network device, and then we define iOS device and XR device, which has iOS-specific data and methods and XR-specific data and methods. The idea of inheritance is that the relationship between the children and the parent class is a relationship. In other words, an iOS device is a network device. That's the idea of inheritance. And we can make use of the common stuff from the base class and have specific detailed differences in the child or subclasses. So going along with this idea of inheritance, in our base class, we can define a method in this situation called getInterfaces. But you know what? For an iOS device versus an XR device, the actual mechanism for getting interface information may be entirely different. For example, an XR device may support netconf, whereas an iOS device may only support CLI type functionality. If I am writing code, I can call getInterfaces on either one of these specific device subclasses, and I will get returned to me the appropriate interface information, and I do not need to know about the differences between an iOS device and an XR device. So very powerful mechanism that's part of object-oriented programming is this idea of overriding methods. Another thing that's important to remember and that you might want to make use of is the idea of composition. And as you see down here on the bottom left, the relationship between an item that is part of an object and its object that it's part of has a relationship. So in other words, if you look up here at the picture, you can see that a router has a interface. In fact, it has a number of interfaces. We might be tempted to say, hey, I want to use inheritance in order to accomplish this, but that would be wrong because an interface is not a type of a router. It is actually a component that is part of the router that's held by that router. So this is an alternative to inheritance. Sometimes you can get into trouble if you try to inherit too much. And the thing that you should be aware of is that, yes, classes can contain other classes. This is the idea of composition. And we give a couple of examples here. A router is a networking device. That's this relationship. But a router has a set of interfaces. A wireless controller is a controller, but a wireless controller has a set of wireless APs that it controls. So hopefully this has given you a little bit of an idea about inheritance and overriding methods, etc. We're going to now look at a demo that demonstrates some of these capabilities. Okay, so here we are in a demonstration of some of the more advanced and interesting capabilities of object-oriented programming. In particular, we're going to look at inheritance, and we're going to actually see how you will create device subclasses for networking devices in your network. So we're going to use this devices file that we have used before. There are 8 different devices in here. Notice there are different OS types. There's iOS, there's NXOS, iOS XR, iOS XE, etc. That will be important when we look at the code. let's look at the code and see what it is that it does. So here's my code, and here's my definition of the base object or class type for a networking device. So networking device is going to have a name, an IP address, a username and password, and I'm going to be, in my initialization function, I'm going to be setting self.name to the value that got passed in as name, IP address, username, and password. Since this is just a generic base class, I don't know the OS type, so I'm going to set that to unknown. Now you can see I'm going to define my subclass called Network Device iOS. The way that I reference the base class or the parent class is within parentheses. So I'm specifying to Python, hey, this is a new class, but it inherits from this other one that I've defined earlier. So I'm going to inherit from networking device, and you can see all I'm going to do in my initialization routine is call the parent's initialization routine, passing in these values, but I'm going to set the OS type to the particular value. This is network device iOS. I'm going to set this value to iOS. And you can see the same thing is true for network device XR, with the difference being that I'm going to set this value to XR. So my read devices info is a little bit more complex than previous ones, because what I'm going to do is I'm going to read in the device list as I go through it, and based on the type of operating system that is running for that device that I've read from the file, if it's iOS, then I'm going to create network device iOS. If it's iOS XR, I'm going to create a network device XR. So I'm creating different device objects depending on whether the operating system is iOS or iOS XR. And I'm going to return this list of devices. In any case, I'm going to add this device no matter whether it's an XR or an iOS device. I'm going to add it to the list of devices, and I'm going to return that list of devices. Now in my print function, I'm going to go through and I'm going to print these devices out. In this situation, devices list, remember, has a list of network device objects. And the good news is that it doesn't matter if it's an iOS or an XR device. They all have the common member functions called member variables called name, OS type, IP address, username, and password. And so we can pass those out. We can print those out whether this is actually an XR device or an iOS device. It doesn't matter because we're referencing the same attribute in this device object. Our main code is very simple. We read the device info from our device's file, and that file information is going to get placed into this list of devices. Remember, this list of devices is actually a list of network device objects. And then we're going to call print device info, and it's going to print the information per the print statement that we just observed. So let's exit here and let's run it and see what happens. So here's the output. You can see that I have outputted only the devices that I cared about. So I created device objects only for iOS devices and for iOS XR devices. Remember, I used the same print statement to print these objects out. It didn't matter to me whether they were iOS or XR because they shared all of these common values. So it makes it very easy to print this stuff out in a nice and easy to read and understand fashion. So in this particular demonstration, we have looked at using inheritance to create networking device objects that are particular to an XR device versus an iOS device. And you could build this out for more devices as well. And in other labs and examples that you'll see in this section, we'll see how connecting to two devices might be different and how you might gather information from devices in a different manner. And so this is the power of using object-oriented programming, and in our case using network device objects that are particular to the specific device type. And hopefully this has helped you to understand the power and the value of using classes and objects in creating your network programmability application. So thanks for listening to this section where we dove a little bit more into object-oriented programming and understood composition, understood inheritance a little bit more, and understood the idea of overriding methods and how these powerful tools can be useful to you as you write your network program.